Now let's look at the problem of solving system of linear equations by graphing. So let's look at an example. So an example is x plus 2y is equal to 2. X minus 4y is equal to 14. So to solve by graphing, there's basically just a few steps. The first step is to graph line number 1. Second step, graph line number 2. Step number 3, estimate where they cross, or estimate the point of intersection. And it turns out sometimes it's easier to graph them using one method or another, and it doesn't necessarily matter. Let's look at an example. So let's look at this problem. X plus 2y is equal to 2, x minus 4y is 14. One way to graph this is to rewrite both of them y equals mx plus b. So let's go x plus 2y is equal to 2. Subtract x and subtract x, and you get 2y is equal to minus x plus 2. And then divide by 2, and you get y is equal to minus 1/2 x plus 1. There's your first equation. Let's go ahead and graph that. So if you graph that, then the y-intercept is 1, so that's the point right there. And then the slope is a negative 1/2, right? So y-intercept is 0, 1. Slope is minus 1/2. That's down 1 and over 2. Down 1 and over 2. You just need one point, but you can use 2 if you want to. And let's go ahead and draw that line. That's x plus 2y is equal to 2. The second equation here is x minus 4y is equal to 14. That's minus 4y is equal to minus x plus 14. Divide by minus 4, divide by minus 4, and divide by minus 4. And you get y is equal to 1/4 x minus 14/4. That's the same as, let's see, that's 7 over 2. 7 over 2 is 3.5. Normally I like to leave it as minus 7 over 2. And the exception to that is when I graph. When I graph, I like to go ahead and write it as a mixed number so we can see what it is. So that's 3.5. A little bit harder to graph negative 3.5. The y-intercept here is 0, minus 3.5. So that's 1, 2, 3.5. That's about right there. The slope is up 1 and over 4. So if you're 3.5, up 1 would be up up to negative 2.5 and over 4. 1, 2, 3, 4. Up 1, 2, 3, 4. Let's see if I did that right. Up 1 over 2, 3, 4. Up 1, 1, 2, 3, 4. Right, roughly there. Draw the line between them. Now we won't necessarily get an exact answer here, but we'll get an approximate answer. And that's why it's often, instead of saying solving, it's often the question is phrased as estimating. It looks like to me it's 1, 2, 3, 4, 5, 6, and 1, 2, minus 2. It looks like to me the answer is 6, minus 2. You can kind of plug them in to see. Now the problem is if it's not the exact answer, they won't be exactly true, but you can at least get a sense of whether you're on the right track. You have to plug the first number in to check it. So you get 6 plus 2 times minus 2 is 2. 6 minus 4 is 2. That works out. And then you get x minus 4y is 14. 6 minus 4 times minus 2 That's 6 plus 8 is 14. It looks like that's the exact answer to me. And that's how you solve systems of linear equations with graphing. Let's do another example. Let's do y is equal to 2x minus 10. X minus 4y is equal to 5. Again, the steps is to graph both of these. Now the first one's fairly easy to graph. It's already written y equals mx plus b. Let's go ahead and graph that. So that's the y-intercept. So the y-intercept here is 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The positive. And, oh no, it's a negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's right there. And the slope is 2 over 1. So that's up 2 and over 1. Up 2 and over 1 again. Let's draw the line. Now this next one, to graph this one, you could write this y equals mx plus b. I'm going to find x and y intercepts. It doesn't matter. X-intercept y is equal to 0. So that's x minus 4 times 0 is 5. So that's x is 5. So that's 5, 0. 1, 2, 3, 4, 5, 0. And then the y-intercept, x is equal to 0. I get minus 4 times 0. Oh, no. Let me do that again. I get 0 minus 4 times y is equal to 5. Minus 4y is equal to 5, or y is equal to minus 5/4. So the y-intercept was 0, comma. I'm going to put that into a decimal. You can do it on your calculator if you want to. That's minus 1.25. Minus 1.25 is just about there. Draw this line, and I'm going to try to estimate where they cross. It appears that this is fairly straightforward. This is your solution right there. Your solution here is 1, 2, 3, 4, 5, comma 0. 5, comma 0. To check it, you would just plug it in and see if they work. Let's go ahead and do that. Our original problems were y is equal to 2x minus 10, x minus 4y is equal to 5. We're checking the solution 5, 0. Now, if it's an approximate solution, it won't be exactly true. Let's plug that in, and you get 0 is equal to 2 times 5 minus 10. That checks, right? 0 is equal to 0. And then let's plug it into the other equation. Remember, you always have to plug it into both equations. So that's 5 minus 4 times 0 is equal to 5. And that seems to be right as well. Anyway, that's how you solve systems of linear equations by graphing. There's basically 3 steps. Graph the first line, graph the second line, see where they cross.